Okay, last video that we did on phase shift, it really was not that bad. Although I realize your head might be spinning after watching it. You might want to go back and rewatch it again. But pretty much, we're just saying we can take a trigonometric function, y equals sine x, y equals cosine x, and we can take the whole sinusoidal curve, the wave, and we can shift it one way or the other by adding or subtracting something in the parentheses. And I just want to start with a quick practice example. I have up here y equals 1/2 cosine 4x plus pi. And so hopefully you'll notice we've got an a term, a b term, and a c term. And what the question says is give us the amplitude, the period, and the phase shift. And then it asks us to graph at least one full period of it. So I know that my amplitude is pretty much straight up the absolute value of my A term. And my A term is 1/2. Absolute value of that is 1/2. So that's my amplitude. That means it's going to rise up to 1/2. It's going to fall down to negative 1/2. That's going to be the maximum and the minimum points. That's it. All right. If we want to do period, I know that I do 2 pi divided by b. So it's going to be 2 pi over 4. And that reduces to pi over 2. Again, half of the question is just asking us to identify what's the amplitude, what's the period. It's identified. What's the phase shift? I know that's my C value over my B value. So pi over 4 is the phase shift, how much that is shifted. And I also note, because this says plus, it's shifted pi over 4 to the left. That means not only fractions, I have to do some subtraction also, but hopefully we can handle that. I've got my amplitude, I've got my period, I've got my phase shift. I know that this is a cosine function, and hopefully I can remember some stuff about cosines. I know, thankfully, it's not inverted. There's not a negative there. But let's see if we can graph this. All right. Hopefully that graph doesn't run off screen. Remember, I'm going to label the top, and I know it's 1/2. I'm going to label the low point negative 1/2. I'd like to label a full period. I know that the period is pi over 2, and I know I like to divide that into fourths or 4 parts. Only thing is, because there's a phase shift, and I don't want to make this too ugly or messy, I might do all of the shifts first. I might want to mark those points. Here's what I mean. I know normally I would start at 0, and I would end at pi over 2. All right. If I were to cut that in half to find halfway, that would be pi over 4. Hopefully you guys get good at cutting a fraction in half, just double the denominator. That's the way we would do it. So now let's cut that in half to find our first 1/4 increment. That's pi over 8. All right. So we're jumping by 1 pi over 8. 1 pi over 8. 2 pi over 8, which reduces to pi over 4. That's going to help you know what this one's going to be. It's going to be 3 pi over 8. And finally, 4 pi over 8, or pi over 2. These are my 5 key points if I didn't have this plus pi thing going on. That's shifting it to the left, and it's shifting it this far, pi over 4 to the left. So for each of these points, I have to subtract pi over 4. Minus pi over 4, minus pi over 4, minus pi over 4, right? First thing I see is 0 minus pi over 4, negative pi over 4 is going to be my new beginning point, my new 0 point. And I'm going to end at 2 pi over 4 minus 1 pi over 4. So I'm going to end at pi over 4. And again, maybe the trickiest part is just cutting this into fourths. I can see that 0 is actually going to be the halfway point instead of the starting point. And you can do all of your math, or hopefully you can look at the graph and maybe see. This is going to be negative pi over 8. This is going to be positive pi over 8. And now here's all that happens. Cosine, in a regular cosine graph, please remember that at 0, at the beginning, cosine actually starts up at the high point. In this case, the high point isn't 1, it's 1/2. So now that I've shifted this far to the left, it's going to start at the high point here. And then at the next increment, it's going to go to 0. At the next increment, it's going to go to the low point, back to 0, and back to the high point. And so that's my cosine graph. Normally, I'd have that same exact shape for one period, but it would have started over here. And this is all just slid pi over 4 to the left. That's an example of that, practicing it through. Again, you try some on your own. We'll get to do some more as a class. Last thing I want to show you is actually much, much easier than that. One final thing that we can do with the sine wave or cosine wave is to translate it up or down. That's called a vertical shift. It doesn't have any other fancy name than that, just a vertical shift. And that's the D value. Okay, what we have is y equals a sine bx minus c plus D. And so D is the very last thing tacked on. Is do we just add something? Do we subtract something? And again, this is not completely new to you. You did this with parent graphs before. Usually when we added something at the end, it just shifted it up that many spaces. If we subtracted something, it shifted it down that many spaces. It's the same exact thing here, right? Let's start with the most basic again. We do y equals sine x I'm kind of not messing with my A, B, or C. My A is 1, which means my amplitude is 1. My B value is 1. That means my period is 2 pi over 1 or 2 pi. My C value is 0. It doesn't exist. There's no parentheses here at all. So you don't have to shift it to the right or to the left. And let's just graph this basic one. Remember, the full period is 2 pi. We divide that into 4. And sine starts at a 0 point, goes to a high point, 0 point or midpoint, low point, and back to midpoint. There's one full period of y equals sine x. Now, if I did, I'm going to pick another color. Let's do that, because otherwise I'm going to run myself out of room. y equals sine x plus 1. Again, a is just 1, b is just 1, c doesn't even exist. Don't think that this is the c term because there's no parentheses. This is tacked on at the end. It's added at the end. And what it means is every single point here just lifts or raises by 1. If this said plus 7, everything would go up by 7, right? Another way to look at it, and if you look at your notes, it says D represents the vertical shift. The positive D will shift up and negative D will shift down. And the midline is Y equals D. Let me clarify. What does that mean? This one, we said it didn't have a D value. So essentially the D value is 0. There's 0 here. And so the middle line of this graph is Y equals 0, which it is indeed. That's my x-axis, right? This one that says my whole graph is shifted up by 1. Another way to see it is my new midline is 1, Y equals 1. I'm just going to dot that here for you to see. And so everything shifts up 1. Where this graph started at 0, this graph is going to start at 1. This graph then next went up to 1. This one's going to go up to 2. Hopefully we won't get too busy there or run into my equations. 0 goes up to 1. Negative 1 goes up to 0. And 0 goes up to 1. And so my graph it's exactly the same shape as y equals sine x. Just takes the whole graph and shifts it up 1. Again, if it was plus 7, it would shift up 7. And my middle line would be y equals 7. If it was minus 3, it would shift down 3. And my midline would be y equals negative 3. Let's run through a quick example, then I'll let you guys practice on that. Says graph one period of y equals 2 cosine x plus 1. All right, so here's a couple things I need to look at. I do have an A value. Okay, so my amplitude is 2. So whatever my middle line is, it's going to raise 2 above that, and it's going to go 2 below that. Thankfully, my B value is just 1, so there's no change in my period. It's 2 pi. My C value is 0. There's nothing else in parentheses. I don't have to worry about phase shift. So we're keeping it a little simpler just so we can practice this vertical shift. And the vertical shift is plus 1. It shifts up 1. So here's my graph. 1, 2, 3. So normally my cosine graph would have a midline of 0, and it would go up to 1 and down to negative 1. And then because my A term is 2, it would actually go up to 2 and down to negative 2. But this says it also shifts up 1. So let's do this. Let's put 2 pi is a full period. This is pi over 2, 3 pi over 2. And where if this was not here, if it was just 2 cosine x, remember cosine usually starts at its maximum point and it would be up at 2, but I do plus 1, it actually is going to start up here at 3. And I also want to remember that the midline is y equals this, y equals 1. Sometimes it's helpful to just put a dashed line there because I know I'm going to go 2 above that and I'm going to go 2 below that. So hopefully y'all can figure out this is going to bottom out at negative 1. 2 below y equals 1. But I go from a high point at the next increment, I'm at the middle point, 1. At the next increment, I'm at the low point, negative 1. back to the middle point, and back to the high point. And so it's still going to look like one period of a cosine wave. But the amplitude on this is 2, and everything has shifted up a value of 1. So we can do lots and lots of stuff with trigonometric graphs right now that you never would have thought possible, and you might still think it's tricky, but you would be surprised. Just take it piece by piece. Let's identify my A term, my B term, my C term, my D term. What does that mean as far as my amplitude goes? What does that mean as far as my period and my phase shift and my vertical shift? You've got some homework questions that you can tackle. And I kind of gave you an overview of this is the way we should go about it. First of all, let's go right to the D value. And we'll see, is there a vertical shift and where would my midline belong? Then we'll look at the amplitude, my A value, and we'll say, all right, if this is my middle line and my amplitude is this, where am I maxing out? Where am I bottoming out? We'll figure out those. And then we're going to find our period. And remember, we're always going to divide it into fourths. So we might either just have to find the B value, or we might have to find the B value and then shift it left or right because there's a C value also. But that's how we're going to complete the graph. And you practice those and come with your questions. We'll work on them together and we will master this soon enough.